How's everyone doing? You're back with Jono for another quick math lesson. Today we're going to look at how we can use bearings to answer really easy trigonometric questions. This is something that can be really useful in real life because it can tell us the position of objects based on their position compared to us. So a right angle triangle is always made from our bearings because essentially the position that we are in space is some distance north or south, which is a vertical line, and some distance east or west, which is horizontal. Because we've got these two dead straight lines, we've always made a right angle straight away. So that means if we draw a problem correctly, we're just left with a right angle triangle question, which we're incredibly good at. These questions are usually just one step of maths, and most of the marks come from understanding and interpreting the question correctly in order to access these marks. So we're going to have a look at a question now. We've got this guy Reggie, and he's walking for 700 meters at a degree of 227. So that means we know that he is going southwest. He's in between south and west. So if south is 180, which we know it is, and Reggie's going at 227, to find out the angle that he walks this way, this angle is what's important. Reggie's gone 227, south's 180, so 227 minus 180 is going to give us that angle. So for this example, it's 47 degrees. We also know that he's gone exactly 700 meters, so we've got two bits of information. So now it's really important to read the question. If we're interested in finding how far west he's gone, we're going to make a triangle that uses that horizontal line. But for this one, we're trying to find out how far south he goes, so we're going to use that as one of the sides of our triangle. So I'm going to move this all the way over to here, and the question is asking for, hey, what is this southerly distance? Because we've now got an angle of interest, the 47, we've got a hypotenuse, and we've got an attached angle, I know I can use cos in order to find that distance. So the maths for this question is just cos 47 is equal to x over 700. To get x by itself, I have to multiply 700 over. So 700 cos 47 is equal to our unknown x. So if you just type that into your calculator, you get that x is equal to 477 meters, which makes sense because it can't be more than our hypotenuse. So we know we're probably on the right track. So we're just going to have a look at another example where we've got to use Pythagoras as well in order to find out more information. For this one, we want to find out what angle did we go off on and how far did we actually travel? How far away are we from where we started? So for this one, we've got a ship has traveled 15 kilometers north and then 35 kilometers west. We just have to map that out exactly, kind of like you're following instructions for a treasure map. So on our compass, we're going up 15 and across 35. And I want you to label those sides immediately. So we've got 15 here and 35 over here. Obviously, because this is trig, I would like you to make a triangle, and this is the distance we are from home, and we're going to call this D. And because we've got two sides, that gives us an angle of interest. We need to know where we are from the origin. So not that top angle, but this one down here is our angle of interest. So I'm going to find out the angle first, and then we'll find out how far away we are from base camp. So because we've got the opposite and adjacent, we've got tan of our angle of interest is equal to opposite, which is 35, over 15. To find the angle by itself, we just have to do the inverse of both sides. So theta is equal to tan minus 1, 35 over 15. And if you type that into your calculator, you got the answer of 66.8 degrees. Now, it's really important that that's not where you leave it. We have to make sure we're actually getting the bearing. So the 66.8 gives us a little bit of the information, but that can't be where we finish. So because we've gone from north towards the west, to find out our final bearing, we've got our 360 degrees, which is north, minus our answer, or 66.8, and that gives us the answer of 293.2 degrees. And that's our answer as a true bearing. And then to find the total distance that we are away from the base camp, we just have to use Pythagoras' theorem. So we've got 35 squared plus 15 squared is equal to our distance squared. If you throw that into your calculator, you've got that the distance squared is equal to 1450. in order to get d by itself, we just have to root both sides. So our distance is equal to 38.1 kilometers away from base camp, which again we know is a good answer because the hypotenuse has to be longer than both sides. I hope you found this lesson helpful, and I'll see you again soon.